On March 19, 2022, a 79 million cubic meter intrusion of magma rapidly rose from 26 kilometers to 1 kilometer below sea level on Portugal's island of Sao Jorge before it ceased its upward motion, just barely avoiding an eruption by an estimated 65 to 90 minutes. While the proper conditions ended up not existing for this magma to generate a volcanic eruption, in hindsight it was concerning for one key reason. The vast majority of the magma intrusion rose aseismically or without earthquakes, and this is a potential concern with implications in terms of world volcanology, specifically regarding how monitoring of select volcanoes is done worldwide. Currently, not every active volcano around the world has a decent enough sensor network to be able to detect all magmatic intrusions that occur underneath their edifice. In fact, I'd go as far to say that at least the slight majority of volcanoes fall under this category, either having no scientific equipment or only minimal scientific equipment present. This is due to a few reasons, some of which are outlined here, largely relating to cost. Thus, the only active volcanoes that tend to receive a sufficient sensor network are the ones with the highest numbers of recent eruptions or proximity to large populations and/or highly important infrastructure. All other active volcanoes that don't fit under one or more of those categories largely rely on this train of thought, that if a magma intrusion was to occur at an active volcano, that even if no sensors were present on its edifice, that satellites or distant scientific equipment would be able to pick up that something unusual might be occurring. Scientists could then quickly install a proper and more thorough network, gather data, and issue warnings, evacuations, and get a general sense of the nature of any ongoing unrest before an eruption begins. And it just so happens that this logic works the vast majority of the time, requiring less expenses than a more constant, thorough network. This process can occur quickly, but generally takes 3 to 5 days. Yet, the 2022 Sao Jorge Intrusion, which occurred at a volcano that had a limited but not thorough monitoring network before the intrusion began, proves that this logic does not always work, since magma rose 25 kilometers and nearly erupted in only 22 hours. In specific conditions, magma can either intrude so rapidly that 3 to 5 days is too late to issue warnings, and/or intrude mostly aseismically that unless a thorough sensor network was on a volcano, its presence would probably go undetected. Even though the limited sensor network on Sao Jorge on March 19, 2022 did detect earthquakes, since these only occurred at 5 to 9 kilometers depth for a time, despite the fact that magma had already reached even shallower depths without seismicity, a limited sensor network might also give a limited, incorrect picture of the ongoing situation that a more thorough sensor network would not. Now, based on my current knowledge of world volcanoes, the scenario I described is, in my opinion, not possible at every single active volcano. However, it does, in my opinion, seem to be more likely for mostly silent and/or very rapid intrusions of magma to occur at a volcano in one particular geologic setting. Specifically, when there is a very close by large strike-slip fault line, especially near or actually representing a plate boundary that extends most or all the way through the crust. These large fault lines in of themselves do not always need to represent paths of least resistance for magma to intrude into, as sometimes their branching faults can do the same thing. The largely aseismic intrusion of magma into one such branching normal fault of the major strike-slip fault line known as the Great Sumatran Fault went undetected until it generated a fatal volcanic eruption at the Marapi volcano on December 3, 2023. While it is fully possible that I am unknowingly misrepresenting the level of monitoring on Marapi before that fatal eruption, in my opinion, it seemed like the volcano only had a limited sensor network present that was unable to detect that intrusion, not due to the fault of any people, government, or volcano monitoring agencies. Now, while it isn't fully certain that a more thorough monitoring network would have always been in hindsight able to detect that same magma intrusion at Marapi before it generated a deadly eruption, it should have been more likely to detect it. Thus, I suggest the following changes to help reduce the chance of similar scenarios from occurring worldwide. More funding needs to be spent placing and maintaining thorough enough monitoring equipment networks at world volcanoes, not just at active volcanoes that fall into one or more of the three shown categories, but also these three additional categories. If these changes are made with a more proactive rather than reactive approach, silent or rapid magma intrusions will be detected at a far higher rate, meaning less unexpected and fatal volcanic disasters would occur. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.